Good morning, everyone. I'm really proud to be opening the INRG. No, that's of course. No, of course that's not my duty. I shouldn't do that. Welcome everybody to this educational session. I think we have a nice program, but first I would like to, of course, invite Kate Matthey to give the first word to everybody of you.
Thank you. Thank you, Jan. You took it away from me, but it's okay. We got our coffee. Welcome, everybody, to this. It's really day -1 of our INRG 2018. I'm so happy to see so many of you here. And I just wanted to outline a few things, which I'll probably go over tomorrow, too, for the whole group. But in your program is the app, if you haven't found it, which gives you the program on your iPhone or your smartphone. And you can also access all the abstracts that way, the full abstracts, which out of courtesy to you, we didn't put in the printed program, so you wouldn't have so much to carry. Starting tomorrow, there will be a light breakfast every day at the Pacific level where the posters will be as well. But for today, there will be coffee breaks. And after there is, at lunch, there's a GD2 symposium, and there's an ANR advisory board meeting, and others can have lunch on their own. There are many, many places right around the hotel and right across the street in the ferry building are multiple little places where you can get small lunches, sandwiches, or sit-down lunches. And to this afternoon, we have 2 consecutive workshops, which will be very exciting. The first one is on immunotherapy beyond GD2, and the second led by Crystal Mackel and Ira Melman, who is a PD-1 expert. And then there will be a second workshop on biomarker technologies. So I think these will be really excellent, and they will be here. Most of the meetings starting tomorrow will be in the main ballroom area. And there's also a young investigators reception tonight with mentors starting at 5:30. So I wish you all well. If you have any questions or problems, we have wonderful people working at the registration desk, and you can also contact me or Bill Weiss or Steve Du Bois, or the co-chairs of the program committee and organizing committee. Now I'll let you enjoy a terrific program organized by Julie and Jan. Thank you.
All right, well, good morning. This is exciting, and Kate and Steve and the committee have put so much work into this, and we're looking forward to a great meeting. I have the pleasure of introducing Susan Cohn, professor of pediatrics at the University of Chicago, and she will lead off our update course, telling us about the newest and greatest for the International Neuroblastoma Risk Group database.
Well, thank you very much. It's a pleasure to be here. And Kate, congratulations. I met her in the foyer. Where are you, Kate? Did you leave? Oh, I met her in the foyer as I was walking in, and I said, this is just like a bar mitzvah and a wedding all combined. So congratulations. So I'm going to talk to you about this International Neuroblastoma Risk Group Data Commons. Some of you may be familiar with this, and some of you may have never heard of this. So please forgive me if you've heard some of these slides before. I really want to stress that we developed this database, and I'm going to, again, go through a little bit more of the details for this research community. And there are data available for folks who are interested in doing a variety of different types of analysis, and I urge you to take advantage of this infrastructure and ecosystem that we've developed for this particular group. So as everybody in this room is aware, international collaboration is required to further advance the care of children with neuroblastoma. And until recently, what we were using for risk criteria to decide how best to tailor therapy differed. For example, for local regional disease and SIAPIN, factors included surgical risk factors, NMIC status, and age to determine how to stratify therapy. And in the Children's Oncology Group in North America, we used age, INSS stage, MIC-N status, and histology. So it was really apples and oranges, making it impossible to compare clinical trials across the world and figure out what therapy worked best. And so in an effort to be able to come up with some uniform criteria to classify patients, in 2005, an INRG task force was gathered in Whistler, Canada, and we had 52 investigators from around the world from various subspecialties, including clinical trialists and biologists, as well as statisticians. And our goal was to come up with some common language to define pre-treatment classification so that a child who is classified as high risk in Europe would also be classified as high risk in North America, and then we'd be able to compare and contrast clinical trials. Our second goal was to support neuroblastoma in clinical and translational research. So in terms of the first goal, we've actually reached, we've had several successes. Indeed, we have developed a pretreatment classification system that was published in 2009. We also developed a staging system to go along with this pretreatment classification system because the INSS staging system was based on surgery. Surgery is part of treatment, and it was the consensus of this task force that we really needed to have a staging system that defined extent of disease prior to surgery. We also developed a number of international consensus on molecular diagnostics, minimal residual disease, evaluation of disease extent using MIBG scans, as well as guidelines for imaging and staging. So we have the framework now for some common technology, common definitions, and I think we're really poised now to be able to move the field forward. Most recently, Julie Park and Dominique Valtocudo led a task force to develop new criteria to define international neuroblastoma response criteria. So now we'll also be defining response in a uniform manner. So in terms of the second goal, Andy Pearson and I, who co-chaired this task force, recognized that for the first time, we collected data on thousands and thousands of patients to determine what the risk group classification should look like. So we based the classification on statistical analysis of data collected from children who were treated around the world. And all of a sudden, we had all this data available, which had never been collated before in these kinds of numbers. And we wanted to make sure that this data was available to the research community. And initially, we kept the data in an Excel data sheet, and researchers were able to apply for the data and do all sorts of studies that they thought would be of interest, and frankly, studies that never before could be determined or analyzed in smaller cohorts were now able to be analyzed. So for example, this is just a subset of some of the studies. There was an analysis on localized patients who were NMIC amplified, very rare cohort. Vast majority of patients that are NMIC amplified have advanced stage disease. We had a study looking at predictive markers of survival after relapse. There was a study on adolescent patients. Again, 95% of the patients with neuroblastoma are diagnosed less than 10 years of age. Very small numbers of adolescents, so to really be able to analyze this particular cohort, you need thousands of patients. We also had a very interesting study looking at patients with a very unusual metastatic pattern of disease, only to the lymph nodes, stage 4N. We had a more recent paper looking at disparate rates of NMIC amplification in certain subgroups of patients. And then in the last year, there was analysis of neuroblastoma survivors with second cancers. And again, this is a rare cohort. Small numbers of patients have second cancers, but when you have thousands of patients, then you start to have numbers that you can start to do analysis on. I just wanted this group to know that there's a website, INRGDB.org, which is a public website. Anybody can go to it. There's various links on that website that you can click. So for example, if you click the research link, That will take you to a page of all the various projects that people have applied for, and then you can also click on the link and you'll actually get linked right to the PDF of the paper if you'd like to look at it in more detail. So the current status of this database in 2005, when we did the analysis, we had 8,800 patients from around the world. But we didn't stop there. We've been continuing to collect patients and patient data from around the world. And our current status is that we have more than 20,000 patients in this database. We have added new fields, so we now, in North America, I know in Europe, you don't necessarily collect race and ethnicity, but we collect this in North America, so that's been added, at least for the COG patients. And we also have added the study number. So not everybody in this database is on a clinical trial, but those patients who are on a clinical trial, the clinical trial study number is included in the database. And if it's a randomized study, at least within the COG patients, we also know which arm the patient was randomized to. So you know, for example, for those patients who are enrolled on our immunotherapy clinical trial ANBL0032, where we randomized immunotherapy versus retinoic acid alone, we know which patients received the or were randomized to the immunotherapy. We don't know what treatment they received. We just know what they are enrolled on and what randomized what randomized arm they were on. We've also added, as I mentioned, second cancers in the COG cohort. There have been European patients that have also been added to the cohort. There are a couple of papers that were published on the infants studies that were conducted by SciPen, and those patients have been uploaded into the database. We also have recently uploaded patients who have unresectable disease from the SciPen data. And then within the last 2 years, we've received 750 high-risk patients from the SciPen high-risk study. New COG data. In COG, we have things set up a little bit differently than they have in Europe, and we have a biology study, and everybody who's diagnosed with neuroblastoma, whether they go on a clinical trial or not, is enrolled on this biology study, and so all the patients on the biology study are included in the database. And in addition, we have this as a living database, at least with the North American COG patients. New patients who are diagnosed within 6 months since the last update are added. So we have a couple hundred patients added to this database from the COG database and the Data and Statistical Center every 6 months. And we also have follow-up data that's added. So just because a patient was alive in 2005 when we initially reported this data, we now know if they are still disease-free, if they've had an event, or if they have died. Now, despite the fact that I am so proud of this, and Andy and I are just so pleased that this has continued to grow and develop, we recognize that the database has significant limitations. The factors that we use to include in the database are more than 30 years old. Age and histology, as we all know, are surrogates for tumor biology. And then there's been a plethora of new genomic data that's been generated throughout labs across the world, looking at whole genome platforms, chromosome, omics signatures, somatic mutations, lots of information on germline SNPs as well. And those data are not in the original cohort of data that we have in this database. So in 2013, I was very fortunate to be at the University of Chicago, and Sam Volchenbaum and Bob Grossman are both faculty members there. And we developed what's called a data commons. And I'm going to talk a little bit about what a data commons is for those of you who aren't familiar with the term. Sam was incredulous that I had this data in an Excel sheet, and he explained this is not the way to do things. And in 2013, we really need to incorporate the data into a true database. And so what the vision was is that we would take this very rich INRG clinical cohort data, and we would be able to link it to biobank, so you'd be able to know if you're looking at stage 4 patients, how many stage 4 tumors are in a biobank someplace, if in case you wanted to apply for those tumor samples to do some analysis. And then we'd also link it to genomic data that was generated through labs around the world. So this is a data commons. It's basically a cloud environment that can contain all sorts of data. And here I have omics data, genomic data, and patient data. But we also have plans to upload imaging. So you can have imaging data in this data commons. You can have digital path information as data commons. Basically, any data that's generated on a patient can be included in this data commons. So it's a cloud environment, publicly available data sets. There are software services and tools within the data commons cloud environment. And then there are fair digital object compliance, which means that the data are findable, accessible, interoperable, and reusable. So Sam made this picture for me so you can all hopefully understand. Here's our cloud. Here's a researcher that puts data into the cloud. This would be our patient data. So this would be basically the SciPin and the COG Data and Statistical Center. Researchers could also put their genomic data into the cloud. Additional researchers could put additional data into the cloud. And then another researcher could use and analyze the data within this cloud environment. So we were able to take advantage of the protected, BioNimbus protected data cloud, which was developed by Bob Grossman. Bob is a PhD in mathematics, and his specialty is actually big data. And he developed this protected data cloud to hold patient information so that you could manage, analyze, transport, and share large genomic data sets in a secure and compliant manner. And in 2016, he activated the Genomic Data Commons, which some of you may have heard of. This is a huge genomic data set. Bob has partnered with the NIH, and any data that's generated through NCI-funded grants are housed in this particular Genomic Data Commons, and the Vice President celebrated the opening of the activation of this Genomic Data Commons at the University of Chicago in 2016. So this is just an idea. Now, this is largely adult genomic data that you can find in the Genomic Data Commons. There's 4.9 petabytes of data, at least there were in 2016. And you can see there's all sorts of data, RNA-seq data, whole exome sequencing, microarray, SNP, et cetera. 14,500 subjects, 42 cancers. There were, however, target data as well, and so I was the pediatrician, the pediatric oncologist who had the opportunity to show Vice President Biden how one could pull up neuroblastoma data. I was actually showing him how many patients had ALK mutations on our computer screen, and he seemed quite interested. So the current connections that we have with the INRG clinical cohort, we have a connection with the COG biobank, so you can actually see if there's tumor samples in the COG biobank. And we do have some connections to genomic data. We have some array-CGH data from the infant studies that were generously supplied by SciPin. John Maris has an R1 to look at germline and do GWAS, and we've got some GWAS data as well. And then we also have this link to the target data, which is the pediatric NCI-generated data. You do need to have dbGaP credentials to access this data, so you'll need dbGaP credentials, but we're trying to streamline this so that once you have your dbGaP credentials, you'll be able to go to one site to do this. So let me just show you how the cohort discovery tool works. If some of you are interested in perhaps thinking about doing a study, you log in to, there's just a button on our website for cohort discovery. You create a login and you log in. And then you're able to actually screen and pull down the various potential criteria that you're interested in. You're interested in looking at patients, for example, who perhaps have died, or you're interested in, we have actually all sorts of different staging systems in here, including Evans stage, or you're only interested in looking at girls. And then you can click on the various cohort that you're interested in looking at, and you'll see here, this is sort of a list of the patients. You can see it's largely dwarfed by COG, but I've been told at this meeting that more European data is coming. When we initially started, we actually had relatively even data from all the different cooperative groups. And I've also been told that additional Japanese data will be coming shortly. What's very cool, though, is that in addition to all the regular standard clinical variables that we collect, we also have now these external data sites. So there's a link to the GEO data, GWAS data. This is their tumor bank, nucleic acid data, and target data. So you can also click on that. And so, for example, if you do a search and you're looking at stage 4 disease, age between 18 and 60 months, and target data exists, then you end up seeing what your actual cohort is. And then you'll know if there's the numbers of patients in the cohort for you to do your analysis, and then it's just a very simple application to apply for the study. So this doesn't give you the data. This is a cohort discovery tool. There's still an application process to get the data, but we do our best to get you the data as quickly as possible. Right now, we're sending data largely out to investigators, and then you can do the analysis at your home institution. But our hope is eventually we're going to do this whole thing in the cloud. So we're beta testing this now in the BioNimbus Protected Cloud. There'll be a way to actually spin up what's called a virtual machine where you can take your cohort that you're interested in, and then with the proper credentials, for example, to target, you'll be able to pull in your genomic data. The bioinformatic tools will be within this virtual machine, and you'll be able to do the analysis. And Sam and his group and I are working very hard on developing new visualization tools so that their goal is to have someone like me be able to do this. Sam can do this, but we want someone like me be able to do this. So I'm their test. If I can do it, you'll be able to do it. It's the ability to link and analyze large clinical cohort, host and tumor, as well as other data, we believe is going to transform pediatric cancer research, leading to new discoveries never before possible. And I thought I'd just kind of show you some ideas of what I had. So for example, here are some of the studies that were all done basically just on this clinical data many years ago with 30-year-old criteria. But you can imagine if we had genomic data, we could ask, are the molecular drivers in endemic localized versus advanced stage disease different? What are the omic markers associated with outcome? Do neuroblastoma predisposition genes differ in adolescent and younger patients? And what are the genetic pathways that mediate this very unique metastatic pattern of 4N disease? So you can imagine that the complexity and the depth of the types of research that could be done will be significantly advanced once we get more genomic data. Any of you in the audience who happen to be generating genomic data, please come talk to me. We'd love to be able to integrate your data. Where do we go from here? Well, we're working, Sam is working very hard actually to build a pediatric cancer data commons. He's been working with a variety of groups from around the world to kind of leverage what we've built for the neuroblastoma cohort to bring in other types of pediatric cancer. And then there'll be opportunities, I think, to do some pan-cancer analysis. He's been working very closely with the rhabdomyosarcoma and soft tissue sarcoma groups, both in COG and Europe. Has really gotten very far with that already, and I think they're about ready to launch somewhere between 2,000 and 4,000 patients. He's also working with other groups that are looking at germ cell tumors, retinoblastoma, and we hope that this will serve as a paradigm. Once the ecostructure is built, obviously any data at all can go into this. So we think that this is going to end up being really a remarkable tool for anybody who's interested in cancer research. Just want to give a shout out to Sam and his group. He really has a very unique Center for Research Informatics at the University of Chicago with some really skilled folks that are working for him. And then, of course, I want to thank my INRG co-chairs, committee chairs, all the cooperative groups that have been so generous with sharing their data with us. We've had very nice support from a variety of very generous organizations. And then, of course, the parents and the patients who have been willing to contribute and share their data. So thank you very much.